beginning of section 7.6. This section is on proving trigonometric identities. So example 18, it asks you in part A to show that this expression on the left hand side is equal to, it's identical to a half sine 2 theta. We're going to start with the side that you can do something with, okay? So I think both of these you can do something with. You can actually, because when you've got the angle of 2 theta, it feels like you can expand it, reduce it to thetas, and then see what happens. So you can start from the right hand side, or you can approach it from the left hand side. So if you started from the left hand side, let's write left hand side is equal to 2 sine theta over 2 cos theta over 2 times cos theta. And you can see clearly that you have got 2 sine A cos A and 2 sine A cos A is equal to sine 2A. It's a double angle formula. So this can be replaced with a double angle of theta over 2. So theta over 2 times 2 is equal to theta. So it's going to be 2. Let's just actually write it 2 times theta over 2 clearly. And then cos theta. So it's 2 sine theta cos theta. Except you don't have 2 because you've just used it in that using this formula. Okay, so the next one you've got sine theta cos theta. This can be, we are looking for this answer. I think it's pretty obvious what happens here. If I do a half times 2 sine theta cos theta, it will be very obvious that yet again I'm using double angle formula with A being equal to theta. So I've got sine 2 theta, half of it. I do think though, if you start from a multiple angle, this is equal to right hand side. If you start from the right hand side, that might be a bit more intuitive. So you've got a half times, use this formula to expand it, so rewrite it as 2 sine theta cos theta. These nicely cancel, so you've got sine theta cos theta. And then we are going to change that again to 2 sine half of this angle, so theta over 2 cos theta over 2 cos theta, which is my left hand side. Okay, for part B, we have to show that 1 plus cos 4 theta is identical to 2 cos squared 2 theta. So I prefer to start this one with the left hand side because it's always a good idea to go from the bigger angle to a smaller angle, just like I felt this was easier if I did from the right hand side. So starting from the left hand side here, I'm going to use a double angle formula for cos 4 theta because I have got cos 4 theta being reduced to 2 theta. So remember, for cos 2a, you have 3 different formulae. The first basic one is cos squared a minus sine squared a. The second one is 2 cos squared a minus 1. And the third one is 1 minus 2 sine squared a. Now, as you are aiming to have be left only with cos squared 2a, okay, with 2 of them, but it's in terms of cos, we're going to use the middle version. Okay, so we're going to replace with a being equal to 2 theta, so cos 4 theta is going to be 2 cos squared 2 theta minus 1. One cancels and you're left with 2 cos squared 2 theta, which is on the right hand side. So it's proven. So that wasn't a bad example at all. So looking at question example 19, this time we are proving the identity for tan 2 theta. That is going to be identical to 2 over cot theta minus tan theta. Okay, so again, you might think, well, it probably is a good idea to start from the left-hand side because it's got a double angle, and I think that's what I would do. But if you are not sure, you know, maybe just not sure, you'd probably you could express the right-hand side in terms of tan. And so let's just have a look. What would right-hand side in terms of tan look like? So it would look like this. There you go. And then work from that point, okay? So I think you can start from both sides, but I'm going to start from the left-hand side. So the left-hand side has tan 2 theta. So reach for the formula booklet. Tan A plus B is equal to tan A plus tan B over 1 minus tan A times tan B. So let your A be the same as B, then you will have tan A plus A, and over here you've got tan A plus another tan A, if you stick to A's rather than B's, 1 minus tan A and tan A over here. That simplifies to 2 tan A over 1 minus tan squared A, and this here is tan of 2A. So this is the formula. So I'm going to rewrite it in terms of theta. 2 tan theta over 1 minus tan squared theta. Okay, so I need to make it look like this. And we could see clear connection here. You only want to have 2 on the top of the fraction in the numerator. So we're going to get rid of tan by dividing through by tan theta. So you will have 2, let's just do it fully, why not? Divided by tan theta, 1 minus tan squared theta divided by tan theta. So on the top I will have 2 because that cancels. And then you've got 1 over tan theta minus tan squared theta over tan theta. That cancels. You've got tan theta over 1. This one is cot, so you've got 2 over cot theta minus tan theta, which is the right-hand side, which is proven. So if you notice this one, if you multiplied it by tan theta over here, both the top and the bottom, then you would have 2 times tan theta, and then you will have 1 over tan theta minus tan theta multiplied by that, which becomes 2 tan theta, and then expanded, you're going to get 1 minus tan squared theta. So perhaps this would be quicker. I mean, you could have skipped some stages when you said you divided by tan theta. You could have just straight away go onto this part here, so skip a line. Okay, let's move on to example 20, which is the last example before exercise 7F. So we've got root 3 cos 4 theta plus sine 4 theta. And we have to prove that it's identical to 2 cos 4 theta minus pi over 6. Really the easiest way of doing it, you could actually use the method from the previous section, which is on Rsin or Rcos theta plus alpha. But I think it's much nicer and quicker to expand this using addition formula for cos. So 2 cos, we're going to start from the right hand side. 2 cos 4 theta minus pi over 6. So just a reminder, cos A minus B is equal to cos A cos B plus sine A sine B. It's always important to state the rule, the formula you're using. So let's expand it. 2 cos 4 theta cos pi over 6 plus 2 sine 4 theta sine pi over 6. So now we can find the values of these two, which you meant to know, but you can check with a calculator. √3/2 for the first one, and a half for sine. This is 30 degrees. So that cancels, and you have √3 cos 4 theta plus sine 4 theta, which is our left-hand side, so it's proven. We can move on to exercise 7F now.